Whilst.
Whilst
From
in
Mark
space.
Cameron. This is from Mark Cameron.
Whilst in space, have you ever looked away from Earth into the black void?
Yeah.
All
because
the
you can
time.
see.
Yeah,
So you can see the stars.
Oh yeah.
You know, and pretty much all the time you can see the stars.
Yeah. It's not
which
a
is
black
cool
void.
thing.
I mean, it's black, but there's all kinds of little polka dots.
There's all the stars there, and the cool thing is about it, you can see it during the day.
Yeah, you can, and there's more than stars. You can see planets. You can see moons.
You see the gas Magellan clouds of the Milky
you
Way
see
galaxy.
the Magellanic Clouds.
Magellanic. See, I just wanted the Magellan
well, there's a large
clouds.
one
I didn't
and
want
a
to
small one, right?
Yeah.
And then you can see the zodiacal lights.
Whoa.
Those are amazing. Right before
The lights
sunrise.
of the zodiac.
The lights of the zodiac, the zodiacal lights. Okay, you can see those.
Which are
and
what?
Then you
Explain
can see
those
the
to
upper.
us.
Oh well, it's,
I mean, I know what they are, but explain it to the audience.
It's this vertical column of fuzzy glow that comes up perpendicular to the horizon shortly before the sunrise.
Every time?
No, it depends on the viewing angle and such. Not every time, but if the viewing conditions are right, you see this big fuzzy glow that goes way up high, maybe 30 or 40 degrees above the horizon, perpendicular to the horizon, and it's this fuzzy glow. It's a zodiacal light.
But one thing to add to this, I think, which is kind of interesting about being able to look into the black void, is that we can't do that when the sun is out here on Earth. And it's not because the sun is so bright. It's because this atmosphere. Right? The light comes through the atmosphere and refracts, and we see blue. It's scattered. We see blue.
Scatters.
So what we see is we see the blue color because the way the light gets bent. Was it only the low scattered, but it's the wavelength of the light that penetrates.
Yeah, it's 1 over lambda to the 4.
Right, and that's the blue light.
Really
so blue light is what, the low wavelength or the high wavelength?
Low wavelength.
Okay, so only the low wave.
Yeah, the short wavelengths get scattered.
And that's why we see blue.
More than the long wavelengths.
Right.
Here's another one by Nour.
N-O-U-R, Nour.
N-O-U-R, okay.
All right.
How much time do you need to get accustomed with microgravity?
Well, for my missions as the Hubble 2-week missions, my very first day, I felt pretty out of sorts.
Yeah.
And then I felt a little bit better. I think probably by the third day.
Yeah.
And then my second flight, I think I felt pretty accustomed to it.
Yeah, your body remembers
right away.
these things.
But it was a 2-week experience. But I wonder if I would have stayed around for 6 months. So did you find that? I mean, it's a very steep learning curve, right?
Yeah, a very steep learning curve.
So let's say the learning curve goes, whoa, you get really good after, like, say, 2 days, maybe?
Yeah.
What happens? You keep getting better, I would think, even after months. Is that true, or does it flat?
No, you keep getting better and better. And one thing that it takes about 2 weeks for your body to learn to push food through your gut. Because your body's lazy.
Speak for yourself.
It can use peristaltic contractions. It's like a boa constrictor with a big wave contracting through. Your body can use peristaltic contractions to push food through your gut. But it also uses gravity. And when you're here on Earth, it being a little lazy, it'll use gravity whenever it can. Mm-hmm. Now you go into weightlessness. You no longer have gravity to help move food through your gut. So your body has to use peristaltic contractions.
Pete Stroko asks, would like to know the effects of living in microgravity for months on the human body.
Oh, okay. Well, there's to first order, you take a licking and keep on ticking. And it's amazing that something as complicated as a human being can just go into weightlessness, live in space for long periods of time, and come back. At the first order, you don't see any gross discrepancies. However, there's lots of little tiny things that will affect you. Your vestibular system is affected. The distribution of fluid in your body is affected. Your cardiovascular system is affected. Lymphatic system. Your immune system is affected. We're finding our eyeballs are getting affected. The retina, there's some maladies happening in the retina to the tune of 70 to 90% of everybody that goes in space for a long period of time have some measurable retinal maladies. Bone density has been an issue that we discovered a long time ago, and we're slowly getting onto an empirical remedy that will at least keep the bone density at bay for the sake of exploring. So there's lots of subtle changes that happen to your body, and we are investigating these to learn about the human physiology as well as to figure out how to keep people working and living in space in the optimum condition.
And so all those things you mentioned, I think you got everything. I don't know if you mentioned muscles, but muscle atrophy is another thing.
Muscles
but
will atrophy.
But all these things happen for a few different reasons. One is that you don't have gravity working on you like it normally does. So you
basically we're lazy.
Right,
if your body isn't taxed, it doesn't do anything.
Right, it doesn't do anything. So, and it also creates. You mentioned I don't know if you called it fluid shift, but you mentioned the redistribution of fluids. This fluid shift means that your fluids are not going to be held down by gravity like they are here. They're going to pool up higher, and that does a couple things, right? It does.
Yeah, it makes your cheeks swell
big.
up like chipmunks, and your legs turn into little pickle sticks.
It also affects your heart because it's not pumping blood like it normally would.
Yeah.
Right. It's your heart would shrink. Actually, the muscle of your heart would shrink.
Shrinks. Your heart rate decreases. Your blood pressure decreases.
And it affects the fluid shifts because it goes up. It could also affect your vestibular system as
it
well.
sure does.
So to counteract that, exercise is a good thing. It gets the blood pumping, it gets the fluid redistributed, it gets the heart working.
Proprioceptive devices. These are things like I can hold my arm out like this, close my eyes, and I can bend my elbow. And I know, even though I'm not looking at my arm, that it's being held out about perpendicular to the floor, and my elbow's bent at about a 45-degree angle. And the reason I know that is from my proprioceptive devices that tell me my body position, even though I'm not looking at it. And those things, when you're in a weightless environment, get all messed up.